Hello, welcome to our learning session. This is Shakil Ahmed. In this tutorial, we will learn how to tabulate our data. Basically, after importing data to R and then making different modifications in variables like recording, checking for missing values, and replacing them with other values. The next step is to make frequency tables for categorical variables, and for continuous variables we just need to report these summary statistics like mean and standard deviation. But most of the medical studies uh, focus on qualitative data. We have a lot of qualitative variables, different disease conditions, and different uh, type of demographic factors like ethnic groups and race, and you can say different geographical locations. So we have a lot of qualitative variables, and we need to produce tables, at least frequencies for only one variable, that is we just already obtained using frequency table. As you can see, just for example, the categorical variable for income, we just produced table frequency, and we had income in categories, so we just produce frequency table for different categories of income. But now we need to see how two variables are interacting with each other. Basically, we need to check assess the association between the two variables. So first of all, we need to just cross tabulate. Basically, we need to construct a two-way table in which we can see how many people are with low income, or low educated, or high educated, or we have no data on them. So we can just make a two-way table. That is, uh, we need to check the association between two variables. So first of all, we just make the frequencies, and again then we can find the percentages, and you can make percentages with respect to rows and with respect to columns. That is also important. Basically, when you see the percentages in these cells, like if we find the percentage, then you have to clear that you are finding percentage with respect to column, means you are dividing this value on column sum, or you are dividing this value on row sum, that is called row percentage. So we will find percentages by row and columns, and then we can find the cross tabulation for three or more than three variables, and how the results are reported, and how the results are uh, used in your publications. So let's start. We just have data in our R, as we used in previous session. This is data on National Health and Nutrition Examination Survey 2005 to 2018, and we have all the demographic variables. Basically, I'm just talking about the demographic variables to make things simple, as everyone can understand the concepts. Basically, these are the mostly used variables which you can see in your everyday examples. So we can just find the frequency table for a single variable using frequency command with library summary tools, as I have already called this library, that is summary tools here. And we can make a frequency table for ethnicity. So we have 6 ethnic groups with 99 for missing values. So these are the distribution for a single variable. Now we will make a table uh, that is used for two-way interaction. Just I'm copying the codes, and you can See, uh, I'm just making a cross tabulation of education and income. So you just need to use the table option, and then you can see a two-way table. And again, if you are already given the labels to the values, for example, I have given values labels as low income, high income, and don't know. So it is easy to understand, and you don't need to uh, edit the table much. You can just copy and this result on Excel, and you can proceed. So this is a two-way table with frequency. So you can just produce a table of percentages, uh, proportion table of, for example, I'm just making a table that is I call percentage table. So that is proportion table, and we use just the table we have already obtained. So you can just multiply this by the percentage table by 100. Let's see. Also, you can just make a flat table after using the results. You can just check this, and for example, a flat table, you can just first see this table, and then we can make a flat table. So these are the basically proportions, and you can just uh, multiply by it by 100. You will see the percentages. These are no percentages. You will see percentages, right? So this is a two table with percentages, and you can uh, make these two tables in a list, and you can just copy paste to your Excel sheet. So this is two-way table for two variables, and you can see the association between the two variables using chi-square test, or you can use McNemar's test, or you can use Fisher-Exact test. You can use on this for this table on the same set of uh, values. So I'm just using this summary command to produce a chi-square test from this table. So we just know the association between the education and income. So there is a significant association between income and age for this data set. So the degree of freedom is 4, as we had how many cells? 9 cells. And uh, the degree of freedom is basically the r minus 1 into c minus 1, number of rows minus 1 and number of column minus 1. So each factors have two levels and uh, three levels, and just one category is subtracted. So we have total degree of freedom to multiply by 2, that is 4. So this is the uh, chi-square statistics. You can also use just chi-square command directly without making this table. You have two categorical variables, income and education, and then you can just use the chi-square dot test command. So you will see the same value as you obtained earlier. Although there is a little difference in the p-value, but the p-value in the above example is rounded, so it's also 0. Now you can make a three-way table using uh, it is easy if you can just attach the data frame, and then you don't need to uh, call the variable from data. If you just attach your data here, and you can just write uh, for example, this is a three-way table that I called it as table 3, and you can just see how the we can see how the three variables are interacting with each other. So the last variable is, first of all, the education, that is on first level, and then income is nested in education, and then ethnicity is on column wise. So you will see, for example, 906 individuals uh, belonging to ethnic group 2 has low income, and their education is also low. So this is the group. So how many cells we have? We have, for example, 1, 2, 3, 4, 5, 6. 6 multiplied by 3 multiplied by 3. So 6 multiplied by 3, 18. 18 multiplied by 3. And there are 54 groups, I think. So you can just check. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 multiplied by 6. So this is 54. There are 54 cells, and you can again apply the chi-square test for checking the interaction between the three variables. You can just give the use the command summary statistic, summary of the tables. Now our table is table 3, so you can just see the association between the three variables. So this is mostly we need when we are looking for the association between three variables: income, education, and ethnicity. So it just consider basically this as a square table. 9 multiplied by 6, 9 cross 6 contingency table, and just apply the chi-square test as usual as we do for a simple association between two variables. So, but we are not clear which variable is related to which variable, but we can see that three variables are associated and mutually associated with each other. If not, then not. If it is not significant, then we can say that there is no association. So, similarly, you can make a four-way table. These you need to attach the data again, and you can make a four-way table for four variables again. You can just attach your data. I think data is already attached, you don't need to attach again. Then you can just I am just putting four variables now: education, income, marital status, and ethnicity. So it will give a 4 cross uh, association between four variables. Now the first variable is education, as we kept education on first, and income is nested in education, and marital status is nested in income, and the ethnicity is on column wise. So you will see a variable that is I don't know what the dimension is, but you can just multiply all the levels of all variables. For example, education has two levels, and income has four levels. For example, two levels or three levels, and marital status is three. Then you can just multiply all these variable. You will get that many cells. But uh, such type of cross tabulation is only recommended when you have enough number of observation in cell, but you can see many cells are empty or zero in this table, so we don't recommend such type of long cross tabulation. But you can see basically two-way association between the two variables as well. And you can again produce the summary of the table, and that will give you a chi-square test summary and my table 4. So chi-square approximation may be incorrect as the values are very small in different cells, but it's giving some chi-square value that is too large and p-value is 0. So we can say there is association between the uh, four variables, but it's not correct as the values are this most of the cells are empty. Even when we have cell values 5 or less, then we need to go for Fisher exact test rather than using a chi-square test. So that's all about simple tabulation. In next video, I will show how we can produce tables using survey data. Basically, when we have survey data, we need to account for these complex survey weights. Uh, that is basically the every person is attached to a weight when that person is sampled from a population. So when this sampling strategy, sampling design is complex, then you can't just uh, use simple random sampling equal weights to all individuals. So in that case, you need to give different weights to different individual, and then we need to accommodate those percentages, those weights while producing percentages in our data set. Basically, we are basically generalizing the proportion for overall population. We can generalize if we are giving weights. So in next video, I will talk about survey weights and producing this table using survey weighted data. Thank you for watching and